So here's what we're going to learn. We're going to learn about how to describe where a function is increasing or decreasing. Like, for example, let's say I have this function. I know you know it's rising from here in this little zone, but how do you describe that? Yeah, on a test, how would you say it's increasing in this interval from here to here? Well, let's say that this is at 6 and this is, well, it keeps rising forever, so we'd say this is like infinity. You'd say it's from 6 to infinity. All right, so that's the basics of that. This spot right here is a low spot, and there's names for that. Absolute minimum and maximums. And then writing higher degree polynomials in factored form from a graph. So if I know that this hits right here at a certain number like 6, and it hits here at a certain number like -3, you can write the equation based on that. All right, so that's what we're doing today. And everybody take a look at this slide right here. Would you please turn it my way so I can see what percentage of you are now into the right spot with the green slide, and almost everybody is there. Excellent. Okay, so the function is increasing on an interval if it rises as you go from left to right. So would you just color in, and let's go with blue. Everybody take blue and color in the spots on this graph where it is rising. Like it's rising that whole time. Now how would I say that? It's also rising in here. And how would I say that? Okay, so here's how you say it. These are x numbers. And so of that point, there's only one point up here at the top that they've told us. They said it's -3.6 comma, I don't care, because the x value is all that we care about. So I would say, I've come to this conclusion. It's easier to think of it this way. Since these are only x numbers, it's rising until it hits that spot. And what is that? Well, that's from forever to here. And what is that spot? Is it the 3.6 or is it the 0.7? It's the 3.6. So it is increasing from -infinity until it hit -3.6. Now, you could argue about whether you use parentheses or brackets on this, because at the moment that it stops, is it still increasing? Well, not really. But I would even accept it if you put brackets around it. Just never put a bracket around an infinity. So this, you could argue whether you should have a bracket or not on here or not. Because again, it's I don't know, it's kind of a good question. At the moment you stop, or at the very top of the stairs, you hit the very top stairs, you were rising right up until you hit that top stair. But at the top stair, you're not rising anymore, so anyway. Okay, how about decreasing? Well, it's going to start decreasing at, again, I'm going to do this in a different color and just show you. In this zone, right from there to there, that's where the graph is. From here to here, that's where the graph is decreasing. And it's all about the x values. So these both have x values. That's really sweet. I can just say, so from -3.6 to -0.9. So from here to here, it was decreasing. Was it also increasing again somewhere else? Yes, so I have to add another increasing interval. And I'm going to add that in black. In this little interval right from here to here, which I like to show from here to here, that little interval right there is from, the x value is all that matters, -0.9 to, well, what's the x value at this spot? It looks like 1 to me, so I'm going to say 1. And last but not least is the decreasing interval. I'll make that yellow. The decreasing interval from here on forever. And that's from, I'm going to say it's 1 to infinity. That's increasing and decreasing intervals. surprised how hard that is for people. But if you can just remember that it's zones, like from here to here, and it's x values. It's the x values. You'll be okay. All right, moving on. So if I had to give you this on a test and you were answering number 1, just try to answer it, and then I will tell you whether you're right or not, okay? I'd go like this. It was increasing till there. And this whole zone right here. All right, Nick, what do you think? You are correct, sir. Excellent. Okay. Rachel, decreasing. To 1. And that's because of that spot right there. Very nice. And then it starts increasing again. Joel, can you take it over from there? You are correct. There we go. All right. I'm feeling like you guys have this. But I was picking people on purpose. Let's see about random people. Pausing for a second. Negative infinity, it's increasing from, decreasing. Okay, negative infinity to negative 5. Very good. Those are x values, so I know you're doing that right. From there to there, it's decreasing. How about increasing? Tell me the next one. From negative 5 to negative 1.9, because it's the x value right there, from there to there. Okay, I think you get the idea good enough. So what else do we have to know? Relatively, that's a high spot. I like to think of it as like if you live in a neighborhood where there's houses near you, you're either up higher than them or you're lower than them, or you're at about the same level as them. And it all doesn't matter until it rains or snows a lot. You guys know it's going to be a big snowstorm here soon, right? Could be impressive. I've been, I've been not impressed before by snowstorms, so I'm hoping it's an awesome one, but it might just be a little 3-4 inch thing. But after that melts, because it will, it's just not cold enough to stay on the ground. All that snow has to go somewhere, right? And if you are the lowest house in the neighborhood, like you live down here in your neighborhood, then all the water in the neighborhood flows down to your house. And then where specifically in your house? In your basement. So if you happen to live in a house that is in a low spot, my father-in-law, their place is a beautiful place, but they have every time it rains a lot, a huge pool of water will collect in the backyard. What do you think that means about the basement? It's even lower than the backyard, right? Okay, so then there's a special device called a sump pump, which will basically pump water from underneath your house to make sure that your basement doesn't get all like swampy down there. And if you have a really good system, like my father-in-law does, it has a backup so that if even the one pump stops working, the other pump will continue to work. It's got 2 pumps. Because it's that big of a deal. Because if it gets really wet in your basement, it's not good. It can make mold. There's all kinds of problems that come from it. So anyway, if you live in the high spot, like in your neighborhood, you never have to worry about the water. That's a really good thing about living in the high spot in the neighborhood. There's really not much bad about it. Definitely, that's one of the things that's good about it. All right. That is a low spot is called a minimum. A high spot is called a maximum. But the absolute maximum would be the highest of them all. So worldwide, what is the absolute maximum? Mount Everest is up there. I think this is... Mount what? Oh, it all depends on where you're counting from. Okay, so if you're counting from sea level versus the from the base of the mountain, which might be in the ocean. There are some really, really high spots, but it's because you're starting deep under the ocean when you're counting. So it all depends on which way you count. Well, the absolute maximum, it doesn't have to be like height, okay? It could be like the strongest kid. Do you get for your age, there is a kid who is the same age as you who is the strongest in the world? There's going to be one who's the strongest. You got to judge, like you can't probably ever even figure out who it was. But it's kind of like if we had an arm wrestling contest, it would be the kid who wins the arm wrestling contest worldwide. They are the strongest in the world. Could they also be the strongest the kid locally? Yeah. Okay, so could you be both an absolute maximum and a local maximum? Yes, I get that question all the time. It says it right here in the notes, but you can be the absolute maximum and a local maximum. It's both. If you're the strongest kid in this room and you're the strongest kid in the world, you are the local maximum and the absolute maximum. There was one kid, my daughter said it was like he was this ridiculous standout amongst everybody at her high school. She went to Orono. And this kid, they just for fun, like have him bench press people. So they'd put a couple people on top of him and he'd just bench press them. He was just like built like a tank. So he just stood out. I remember this guy in high school too, same idea. He was just huge, just built like a truck. And there was another kid who was just like could run like a deer. It was insane. Like he just flew. He was so fast. And then he got into football, and that's pretty handy in football to be that fast. And you get the ball to the guy, just nobody could catch him. But then he blew his knee out. And it was like, oh, this guy that had this amazing talent for just being like a deer blew out his knee. But some of those people, from my experience, they seemed like they were really strong, but then if you put them up against the rest in the world, the guy would seem slow or weak. All right, because worldwide is a big place. All right, so anyway, absolute maximums, absolute minimums. Can you be both? Yes, you can be the absolute maximum and the absolute minimum. Here's a common real world problem. You got this graph, and kids are asked, does it have an absolute maximum? Yeah, that's the highest spot. Does it have another absolute maximum? No. But it has this spot, which is a what? Relative maximum or local maximum. Either one of those are good. Is that a relatively low spot? Yes, that's a local minimum or a relative minimum. And last but not least, what do we say about the lowest of them all? There's two possible answers. One's right, one's wrong. So listen to the two possible answers. There is no absolute minimum, or the absolute minimum is negative infinity. I want you to really think about this. Is it a better answer to say that there is no absolute minimum, or that the absolute minimum is negative infinity? One of those is right and one of those is wrong. They're not both right. What's your gut feeling?
Negative infinity.
Okay. What's your gut feeling? Okay. What's your gut feeling? Negative infinity, or there's no max or no minimum? What? Okay. What do you think?
Negative infinity.
All right. Everybody's wrong. It's not negative infinity. It is, there is no minimum. Here's why. It's easier to say it with maximums. Let me draw you a picture with maximums. And I draw this picture. Do you get it goes up forever, right? Well, the two choices are there is no maximum, or the maximum is infinity. If I say the maximum is infinity, it implies that it's a place that I can get to. Like that low spot, that's a place you can get to. Like it's a place. And infinity, it's important to understand infinity is a concept. You can't arrive. Ooh, I'm at infinity. Nope. You just moved in a direction. Infinity stretches out forever further. Okay, so can you find the maximum? No, you can't find the maximum. So you can't say that the maximum is infinity because that's saying you can get there. You can't find that place. All right, so bottom line, you say no maximum. It's very tempting to say infinity. That's why I wanted to make the point of asking kids what their gut feeling was. Because a lot of people's gut feeling on this one in a week when we take a test on this will be to say infinity, and that will be wrong. No maximum. And of course, if the graph's back to this way, no minimum. Is there any local minimum? Yeah, but no absolute minimum. The lowest spot of them all. You got to think of it that way. If I say what's the absolute minimum, I'm saying what's the lowest spot of them all? And is there a spot called negative infinity? No, there isn't. Okay, good enough on that. So let's actually do one here. Identify the absolute and relative maximum and minimum values. Well, it feels like it's in one of the spots. Is that a max or a min? It's a max. Is it an absolute max or a relative max? Absolute max. Is it also a relative max? Also a local max? Yes, it's all of those things. How about this one? Not quite as high. So what kind of max is it? Relative max, also known as a local max. Locally, it's the maximum. If you lived on that spot, you're on a really high spot in the neighborhood. Okay, and then there aren't arrows on the end of this, but we're going to assume it goes down forever. And therefore, what can I say about the absolute minimum? None. That spot is called a relative minimum, or a local minimum. Okay, now writing equations. I think this is going to be so much easier if I just show you one. Do you get how this hits at 1 and this hits at -3? And I can write the equation for it. And the fact that it's just cutting through there, you've already seen these before. You remember how it's negative because it's upside down? It's a parabola, so it's got to be an x squared. The parabola has been moved to the left 2 and up 1, 2, 3, 4. Plus 2 and up 4. There. That's not how you're going to do it. That's vertex form. If we're going to use the 1 and the -3, do you remember how I would go like this? X minus 1, x plus 3. But oops, it's upside down, negative in front. Does that ring a bell? Okay. Now what about this one that's bouncing here? Then what you do is this. You go x minus 1 squared. Y equals. If it's bouncing, you say squared. That's called its multiplicity. As it goes through the x, it's either going to cut through like these where it just goes right on through it, doesn't even notice that it's there. And those are called a cut through. You'll have to know these names on a test. Cut through or pass through. And you also have to know that it's got a negative in front so that it's flipped like this one. But it's easy to forget that negative. There's a bounce, which is worth 2 for multiplicity. And last but not least, there's a triple. Do you guys remember this graph? Y equals what? X to the third. Okay? That is a special way to pass through. Yeah, it's passing through the x. It didn't bounce off the x. But that's worth 3. Look, it's worth 3. See? All right, so if I gave you an equation that bounced here, cut through there, and did that little snaky thing, kind of like the x to the third, I didn't do that very well. I'm going to try that again. Sorry. I'm going to start with my snaky thing. They're really hard to draw. And then I'll bounce at, let's say that's 5. It's supposed to be touching. There you go. And this is at 0. Then you say, oh, so the roots are 0, x minus 0, and 5, x minus 5. And it was a triple root at 0 to the third, and it was a bounce at 5 squared. Is it going up on the right? Yeah, so it's positive in front. I don't need to put a negative there. I can leave it positive. There, that's how you do that. The only thing you wouldn't know is the stretch factor, and we're not going to make problems that hard that have a stretch factor, so you don't have to worry about that. Okay, see if you can catch this one. Notice it went through 0. Don't forget about that one. And if you're not sure whether this is one of those kind that is like a snake or not, you can ask. That is not a snake. This is just a cut through. What's the equation? All right, everybody write the equation. It'll be y equals something. It's got a factor for the one, a factor for the other, and if there's maybe even a third factor. And then, I don't want to give you any hints. Try it. Compare it to the kid sitting next to you. See if you get the same answer as them. Did you say x plus 4 for that one? Did you not put squared or anything because this is just a normal pass-through? You could have put a 1, but you wouldn't have had to put any other number there. And the next one I see that just stands out to me is this 4, so I'm going to go x minus 4, and that one's bouncing. That's like a parabola that just touched, and that actually counts as 2 roots. So I put a 2 there. And last but not least, it did pass through 0. There's 2 ways to do it. You can either say x, or you can say x plus 0. Either one is the same thing. Okay, and then if it had been like a triple root there, I would have put it to the third. That I distinctly told you was a pass-through, so I'm just going to put a 1. And I'm so tempted to just circle it and say that's it, except there's one little thing missing. Who caught it? Yes?
Negative.
There's a negative necessary. I bet a lot of people didn't think about it. It's going down on the right, so it's negative. All right, I haven't done much review, and so I want to take a minute to review what you're supposed to learn yesterday, and that's one of them. So if I give you a graph and it looks like this, do you get how it ends going up? Could this be the right equation for it? Let me think. There, could that be the right equation for it? That is impossible that it could be the right equation. Why? Yes, sir.
Because you only have 2 roots on one side and 1 on the other side.
There's clearly 2 roots on one side and 1 on the other, and I have it that way, don't I?
But you have 2 roots on the negative side and only 1 root on the
You are correct. This would indicate that I should have a root of -4 and a root of -6. And I don't have 2 negative roots here. I really only have 1 negative root, so that's not possible. All right, here's another one. Possible or not possible? Possible? Not possible. What do you think?
Not possible.
Why?
Using a negative.
Why? Prove it.
The right side. Excuse me.
The right side is
The right
going
side.
down. Yep, you're right. So there should have been a negative. Okay, now, possible? Not possible. Yes.
It's not possible because this, the other side's on the same side, so it should be a square.
All right, so this is also going down, which tells him that there should be an even degree, like a degree 2, like you said, squared. You're kind of right, but the way I have it right now, there's a 1 here and a 1 here, which means mine is degree 2. So that's not necessarily wrong. How about this? Would you agree that this has 1, 2, 3 turns? Which means it really should be degree... If it's got 3 turns, is it degree 3 or 4? Degree 4. Okay, so this is not the right equation because it should be degree 4. All right, so then today it's more like, here's an equation. Say that's 7. Let's say this is negative 3. And you have to tell me what the equation is. And I got 1, 2, 3 turns, so I'm thinking it's probably going to come out to degree 4, right? So tell me what you think the equation is. AD, back by the flag. Tell me something that has to be part of the equation.
X plus
And tell me a little more.
X minus.
We don't know about the x plus 3. Hint, it's doing that special bounce thing.
Oh, so it's
There you go. All right. Moving over to Riley. Tell me more about this equation. Now, could that be the right equation? Yes. We have never set a scale on how big that is. You always usually make your scales the same, but couldn't I count by like 20s? 20, 40, 60 on this scale if I wanted to? Okay, so we don't know how big that is. How about this? Assume for a moment this is the right equation. Then what's the y-intercept? Finish this sentence. The y-intercept is where x equals 0. So 0 and 0, and then 9, and then 49, and then 9 times 49 is a really big number. So that's a really big number. Now, I just made the point that I could count by whatever I want. See what I mean? So that could be right. It is at least positive. Now, if it was negative, I'd know something was wrong. You know what I mean? Okay. All right, so today is mostly about writing equations and then telling where the equation has these special things called relative minimums and maxes. Does this have a relative minimum? Yep. Does it have 2 relative minimums? Yep. There's a tie for absolute minimum. Do you get what I'm saying there? The lowest they go is 0, and they're both that. So they're both local minimums, and they're both the absolute minimum. Is there an absolute maximum? No. Is there an absolute... No. Is there a relative maximum? Yes, and it's that spot. And then, if I asked, tell me about this interval where it is increasing. Try to write the interval at the end. There, I know there's several. I only want this last one. Tell me the interval for that. So it's increasing from Alina.
from -7.
This is regular 7.
Oh, 7
You are correct. And I just usually use parentheses around both sides. What I never want you to do is use a bracket on infinity, and so just use parentheses on both. I know you could try to argue that this could be a bracket on the 7, but I'm not going to mark that wrong, but okay. There. I think that pretty much covers things. So, does this have a single, a double, and a triple root? Yep. Can you tell which one's which? The triples are the weird ones. Doubles are easy, they're a bounce. Singles just cut through. That's a triple. Okay. Sometimes I call it a snake. Okay. And we've already written equations like that several times, so I think we're ready. So you have a little Schoology quiz as your homework for tonight. And I noticed several of you didn't get your homework done last night. You do have a few zeros that get thrown out at the end. I throw out your lowest two, but try not to let that happen frequently. Some of you have gotten away with it more because I haven't been going through and entering zeros. I've been just leaving them. I'm going to be entering the zeros more often. So just get your homework done. You know you should. And if you're stuck, come up and ask. And that's all I have for you for today.